recording, and I'm coming to you. Hey, hi Goran, how are you?
I'm fine, thank you. Wednesday evening,
Yeah.
standard day for our RFEM session. And you,
Yes.
all good?
All good. Getting tired, but I'm excited to run RFM from you. So
So
let's get started.
hope I can share something
Mm-hmm.
interesting tonight. I'll share my screen.
Mm-hmm.
So, oh, please tell me when you can
Yeah,
see
I
my
can see.
screen.
Oh, it's already a building
Okay.
there.
No, I can. Yes, we will get to this building. I just want to get back each time I get back on our last model and what we did until now.
Yeah.
And last time we speak about the sporting, about putting some generating some load cases and putting some line loads and so on.
Mm-hmm.
So for this time, I decide to create maybe a bit
Mm-hmm.
realistic
Mm-hmm.
model,
Mm-hmm.
so we can go through some other load cases and show for example how to generate area load, how to generate snow load, wind load,
Mm-hmm.
and how to use some RFM
Mm-hmm.
wizard
That's
which
nice.
are inside the
Mm-hmm.
RFM.
Mm-hmm.
And maybe if we have time, we can generate one combination
Mm-hmm.
and prepare all important things for calculation.
Mm-hmm.
And then how we imagine that we will go in further
Mm-hmm.
session.
Mm-hmm.
We will try to calculate one complete model, maybe this, maybe some variation of this model, but we will show then presentation of results, some reinforcement design, and after that creating printout.
Mm-hmm.
So let's do this load cases and combination part today, and after that we are completing those main things, I think, for beginners,
Mm-hmm.
and after that we are starting then with our plan,
Yeah.
making a bit complex geometry and calculation.
Yeah. Exactly. Using grasshopper. Yeah.
Yeah, yeah. Okay.
Looking forward.
First of all, I will get back to our basic tree,
Mm-hmm.
and I will open this tree where we can define our load cases.
Mm-hmm.
Last time we show the generation of self-weight
Mm-hmm.
and live load. Maybe we can keep those two for now.
Mm-hmm.
They are actions, and here are generated automatic combination.
Mm-hmm.
Here on base option,
Yeah.
on base card is the combination wizard.
Mm-hmm.
He's active now. If I use this combination wizard, if I unclick on it, uh, it will ask me if I want to keep or delete all combination which is automatically generated by RFEM. So if I delete all those combination, I see I lost my design combination here on top. But if I again click on this, it's automatically put me this action combination and load combination again active. And then after I go through all these cards, he will automatically generate those load combination, which are automatically generated according the choose standard, which are we already shown in our first
Mm-hmm.
session before.
I'm Goran, one question because I'm architect. What's the difference between action combinations and road combinations?
Uh, let's start from the beginning.
Mm-hmm.
Self
Mm-hmm.
load case, we're defining load case, the
Mm-hmm.
name. This is self weight or live load
Mm-hmm.
according to the action category.
Mm-hmm.
For each those load cases,
Mm-hmm.
he is he is defined as permanent
Mhm.
or for imposed load,
Mhm.
not permanent.
Mhm.
And in action, here is defined action category and
Mhm.
action type.
Mhm.
For example, they are acting simultaneously,
Mhm.
or if we this is a specialty maybe for wind,
Mhm.
because we have wind in four direction,
Mhm.
and it's not possible that wind is
Always for direction, yeah.
always in four direction.
Mhm.
Then we use wind pressure in two direction
Mhm.
and say, okay, you don't you your action type is alternatively or
Mhm.
something like, or
Mhm.
we can choose
Mhm.
which will be active in which time.
Mhm.
Then after that, we have those design situations which we are also explained before.
Mhm.
Those ultimate limit state and serviceability limit states. Those
Mhm.
are state defined by Eurocode.
Mhm.
That first is mean that our building should stay uh, whole in one piece.
Mhm.
There's no mechanical mechanical uh,
Change.
uh,
Service.
there there cannot be failure of
Mhm.
resistance.
Mhm.
And serviceability limit states say that there should not be deflection which are bigger
Mm.
than Eurocode is allowed by Eurocode. So
Mhm. Mhm.
and, and after this, in action combination, here are the load cases
Mhm.
multiplied by safety factor,
Mhm.
also defined by Eurocode or national annex.
Mhm.
And after that, here are final load combination which are used for design situation.
Mhm.
That's the that's all. Everything is defined by standard. It's just separate because in each part is something other possible to define.
Mhm. So the load combination, I know it's the combination of load cases, and
Yeah,
action combinations are combination of.
it just say that this action,
Mhm.
those two combination
Mhm.
are in this ultimate limit states
Mhm.
category.
Mhm.
So when he creates ultimate limit states
Mhm.
uh, situation or
Mhm.
locate combination,
Mhm.
in this case he take in consideration these both of
Ah, okay, I see.
so
Mhm.
for characteristic he take another two,
Mhm.
because at the end in top in here where we can see the
Mhm.
final result.
Mhm.
In this situation, he take in consideration all our
Mhm.
ultimate limit state
Mhm.
action combination. No,
Mhm.
that's
Mhm.
that's
Mhm.
we have four main, and all those category combination are considered by those four. No,
Mhm.
just just defining which action combination is
Mhm.
belong to which load combination.
Mhm.
But the end for us is for us are the load combination
Mhm.
main, which are
The major
yeah, major
result we
ones.
are
Yeah,
looking for. Yeah.
yeah. So okay. After that, we show line load, so we will maybe skip that.
Mhm.
We can just shortly show how to generate area load.
Mhm.
For example, self weight is
Mhm.
self weight. It's self weight of building according the materials which we are choose.
Mhm.
Here I choose concrete
Mhm.
members,
Mhm.
and here on this side I put some steel
Mhm.
members.
Mhm.
Just for example,
Mhm.
we can maybe go to live load
Mhm.
and say okay, we will take in consideration now surface load. Usually,
Mhm.
as before, we have some pop-up screen which we can choose
Mhm.
load type.
Mhm.
We can choose in between force, temperature, Excel,
Mhm.
mass, or something like that.
Mhm.
For us, that's it's now force, and it's uniform or uniform,
Mhm.
uh, and direction is uh, Z direction,
Mhm.
and we will say, okay, it's for live loads. It's also defined amount of this uh, load magnitude is defined by Eurocode.
Mhm.
Also, for example, if we have some standard building for residential building, it's approximately about 2.5 kilonewton per square meter.
Mhm.
Or if this is area for or place where is possible
Mhm.
bigger people where it's possible to came more people like some um, libraries or something like that,
Mhm.
that this amount can be about 3 to 4 kilonewton per square
Mhm.
meters,
Mhm.
or usually on terrace on a balcony is 4 kilonewton per square meters, but
Mhm.
it can be also be defined in national annex.
Mhm.
For example, we will put here 2.5 kilonewton.
Mhm.
That means 250 kilograms
Mhm.
per square meters.
Mhm.
Okay, uh, and after that I can choose which surface this
Mhm.
will be assigned. Okay, this
Ah, so you can choose multiple.
I can choose. I can clear all,
Mhm.
and I can choose. Okay, I want that this case, this
Mhm.
load case,
Mhm.
acting on these two surfaces.
Mhm. Mhm.
Okay, I think it's
Uh-huh. You have to
okay.
put
It's
minus. Yeah.
minus, yeah,
Mhm.
because it's in local
Mhm.
direction. I have up
Mhm.
direction
Mhm.
set, and now I have my area load
Mhm.
defined here.
Mhm.
It's nothing
Mhm.
special, just standard defining.
Mhm.
For us, for engineers, is the most important thing to make clear structure, to make clear analyze of
Mhm.
load case and load amount.
Mhm.
We show last time, for example, how to define load from some uh,
Element.
yeah, from some
Mhm.
floor elements, uh, and that's the simplest way
Mhm.
for generating uh, this. For example, if we try to add, if you imagine that this side is under earth pressure,
Mhm.
that's maybe some ground here,
Mhm.
and this is some. We can also try to add surface load,
Mhm.
but we can maybe try to make linear
Mhm.
distribution,
Mhm.
because always in this case is pressure from earth is bigger with depth.
Mhm.
For example, if we take linear, he will always ask us to pick 3 points,
Mhm. Mhm.
and then usually we are starting first, second, and finished with third,
Mhm.
or we can start. Usually it depends how someone likes to work.
Mhm.
I usually put first two, and I say, for example, if on top is 2.5, and down is 30,
Mhm.
then
Isn't
I
it should it be minus or it doesn't
uh,
matter?
now we will see.
Mhm.
Select the surface. Okay,
Mhm.
here. Okay.
Mhm.
Okay. I saw that I missed. I go the direction, and I will choose
Ah, okay. You can
coordinate
define.
system
Mhm.
local,
Mhm.
and I will say
Why?
my action will be in local direction
Ah,
uh,
okay.
Z. So that means, okay, now I should choose minus, or
Mhm. Mhm.
I should before
Mhm.
maybe uh,
Flexible, yeah. Mhm.
taking consideration this
Mhm. Coordinate
surface
system, yeah.
surface coordinate
Surface
system,
normal,
and
yeah.
then after that, yeah. But
Mhm.
it's not a big problem if I create something which I don't like. I can choose
수제니까.
another
How did you went go
method.
to this menu again? Double click or?
uh, yeah, I just came with my mouse pointer on
Mhm.
this
Mhm.
load,
Mhm.
and put two times
Double click, yeah.
double click, and it's open
Mhm.
again.
Mhm. Mhm.
Yes. So that's the catch. I can try this, but
Mhm.
you will see this doesn't work.
Mhm.
If I try in this case to define, or maybe it will show, uh, some object cannot be considered. okay, it's not possible.
Mm.
No, because in this case he always looking 3 points for 3 points,
Yeah.
and if I give in this
Yeah.
case 3 points from this element, it's not possible to put on this side the same amount. So that's the something what we can also do inside.
So how did you? Sorry, could you repeat to select 3 points again? So
Okay,
surface road and then
yes,
new
new
surface
surface
road,
load. And then I choose not
linear.
anymore
Ah, okay.
uniform.
Yeah.
Then I
Okay.
choose linear. I
I got
see
it. Yeah.
here is
I got it.
yeah,
Yeah. I got it.
and
Okay. Yeah.
here I take see.
Yeah.
So maybe I can put here, here, and here also. And now I will choose.
Here
Okay,
highest.
this
Yeah.
is local Z, local Z. I will choose here
Minus.
0. I will choose -2.5 and -30 because uh, I'm trying to get something mm, 2.5. No, it's not. No, I made a mistake. Okay, okay, I played. Okay,
Point one is it's
yeah,
down there right now. Yeah.
one,
So you can change the nodal
two,
point.
yeah, 2, and I'll say 2.5 minus, and I get the same. Uh,
Nice.
yeah, that's the most used I think way of adding the area
Road.
loads
Yeah.
on surface.
Yeah.
Usually we have some of this option or some of this. Line loads we already show. If we want to put some line loads some elements, we can for example say here, okay, this is on top, there is some maybe signage or something like that put it, we will have some line load from I don't
Kilometer per
know,
meter. Yeah.
kilonewton per
Kilogram per meter.
yeah, kilonewton per meter line length. And I will say okay, global system, okay, and now I see I also made mistake. What he in this case he will separate this load each area for
Each
each
beam.
element.
Yeah.
Yeah, I can easily go here, and I can with selecting this case of one in my tree, he immediately select all loads assigned here. So for example, if I go here and if I take here -5, it will automatically change all those three values.
So this is like a 500 kilogram per each meter.
Yeah, yeah,
Mm-hmm.
per each meter. But that means that I don't know what is on top. Serge, I just but for example, this is approximately maybe 2 meter of height of wall,
Parapet.
brick wall.
Wall. Yeah.
So, for example, 25 centimeters thick. What in other case, what can I do? We show that we can double click on this load.
Symbol. Yeah.
Yeah, if we click here and if we put here -5, then only this will change this value and it will came as second.
So either
So yeah, so that's the difference, because in this case, if we have splitted loads on this, we can choose it and we can say okay, yeah, it's -5, and then it's automatically all those change.
That's very clever. Yeah.
Yeah, so that's maybe okay. Also for nodal loads, we can say nodal loads, same things. In this case, we just choosing nodes on which we are want this values acting. We can say 20 kilonewtons in point load. The same thing. Okay, I made mistake. Yeah, no problem.
Nice.
I will change it, and it will direction.
That's huge road, like 2,000 kilogram for each point.
Yeah, it's okay. Probably if we'll not, if we can make calculation, we will put
Failure.
low.
Yeah.
Yeah, we'll downgrade
What
later.
about you doing this area road? If you want to do the projection road as an area road for, let's say, snow road, is the same option?
If you are okay, let's make one more option from wizard, and then we will show generation of slow load. For example, I think it's very interesting. Because of that I create this area. If we have some, I don't know, we can take in consideration this in some pedestrian bridge or something like that, connection between two buildings. Usually here is some walk.
Moving road, let's say.
Yeah.
Yeah.
Oh, I don't think on moving load. Here we are here on static loads. It's sometimes it's necessary for us to generate area load and to transfer this area load or change it to line load on these elements which are here.
Okay.
And there is one interesting thing in Load Wizard where we can take in consideration member loads from area load.
Okay.
Yeah, so that means if we take this option and say, okay, I want this will be my live load. I can choose load case. Okay, I want uniform distribution. I want Z direction, and I want amount the same as previous, I think minus 2.5, and I can then choose geometry. If you take a look here on the picture on the side, what he do, he takes area loads and he transfer or transfer those load on members accordingly the area which is belong to this member.
Okay.
So for example, if I go here and choose geometry and I put, okay, I want first, second, third, fourth point.
So you construct a plane and then it projects
Yeah,
on
and
the.
he asked me if I want to remove some elements from influence, remove influence from some elements. For example, in this case, I usually want to, for example, to remove influence on this member because I want to transfer all loads on these elements, and those elements will sit on this beam, and this beam will transfer then
to the
complete,
column. Yeah.
to the column. Then I have option to select those elements. I don't know, one by one or by cross section, but also there is an option member parallel to straight member, and then I can choose just this element one, and he will exclude all elements.
Well, that's
from
clever.
So what I now what can I see now? He generate this 2.5 kiloliters per square meters here. But if I go right click here, here is very interesting option. This is new in RFEM6. I like it very much.
So you
You
increase.
see, I can increase the presentation. I don't increasing the load. I just increasing presentation. Presentation of my loads. That's very, very nice. Okay, but if I choose here this option display separately, he will transfer those loads to my elements. That's what I want to get.
Display. This
And
is the
now,
option.
yeah, and I have actually how this acting. I didn't want to choose each element separately and put line load on it. I said to this area, this is my area. Please transfer those loads on these elements for me accordingly the area which is belong. So in our case, because we do simple example, he took half length of this beam. For example, if this is 0.77 meters. For example, he took half of it here, half of it here. So that means 0. 0.70.
Isn't this
70.
more like applying to wind road? Like you have construction plane you draw, and then it
Yeah,
project to the member.
yeah,
Isn't it like
yeah,
something for
yeah,
the
yeah.
wind road
It's yeah,
usually?
yeah. It's usually the same situation.
Uh-huh.
It's almost the same because you see this in same categories
Mm.
by RFM. It's generating using load wizard,
Mm-hmm.
so that means you can apply this load and generate same as
Ah,
the
there on the wizard
power.
you have snow and wind road
Yeah, yeah, yeah,
separately. Okay, I
yeah.
see.
Okay.
And when you like display separately, can you merge again as a
Uh,
projection?
if I
Ah, okay. So you can
move back
always,
this,
yeah, ah,
yeah,
okay.
it will show
Mm-hmm.
again like
Mm-hmm.
this. Okay.
Is it just graphically displayed differently, or is it actually same between the?
It's actually the same.
Mm-hmm. Just graphically,
It's not the same as a
area
standard
road.
load,
Yeah, yeah.
because this standard area load could not be defined in this area
Mm-hmm.
because we don't have a surface
Surface.
which
Okay.
we can assign. And in this case, it's a specialty because we can choose elements where we want
That's
to
great.
apply
Yeah.
this, because we said, okay, if I in some case remove this
Mm-hmm.
element and put OK, then if I put this, show this separately, I
Mm.
can see that he also take in consideration those small
Ah,
elements.
okay, I see.
So that means he
Mm-hmm.
made another.
Mm-hmm.
What is giving opportunity to me?
Mm-hmm.
It's giving opportunity to choose precisely elements on which I want to transfer those load.
Mm-hmm.
So that I
By
make
the
those.
way, which means can you change also the depth of influence? Right now we're just projecting closest element, right? But let's say one of the beam is below of that level, and you want
Mm,
to still influence the beam which is downside, like
No,
no. Ah,
no.
okay. So there's
He
no
can take
depth
no depth. He acting only in
on the plane.
on the
Mm.
plane where we selected those
Ah, okay.
core
But
elements.
is there such an option to control depth for another load wizard? For example, in Sophistic, you can also select this surface plane you can create, and then from there you can control the depth of influence, for the wind
Uh-huh.
road, for example.
Okay.
Yeah.
There is some option to create. Uh, mm,
Hmm.
there
Just
is
question, yeah. You don't have to. If there is something you
no,
don't.
there's few option. There's a surface which is used just for transfer load,
Mm-hmm.
and there is this uh, member loads from free line load, and there is one more option which were free free loads, but I'm not sure that it's possible from this plane transfer load to another
Mm-hmm.
plane. I
Mm-hmm.
usually never done it. I
Mm-hmm.
can be honest. I always trying to be with my loads on correct plane on
On
each
each
top.
each each element.
Yeah,
Yeah.
yeah,
What about the loop on the concrete loop? If you want to give snow road,
yeah.
you use
So
wizard also. Uh huh.
yeah, so here is we can I created two kind of roof.
Mhm.
For example,
Mhm.
here is the monopitch roof,
Mhm.
or how it's called,
Monolithic.
and
Yeah. Monolithic
yeah,
concrete.
one slope, and
Mhm.
here is a
Mhm.
double sided roof.
Mhm.
So we can maybe go then to snow option to see what we can what we can choose.
Mhm.
This wizard is very nice,
Mhm.
and here, as I speak, we can
Mhm.
choose
Monopitch.
flat
Mhm.
here or monopitch. It's flat. We
Mhm.
under some angle we consider as a flat.
Mhm.
After some angle, it's monopitch, and
Mhm.
if that's dual pitch, then we have two
Mhm.
slope.
Mhm.
For example, if we choose this first one, what he asked for us, he asked first to
Loop.
choose, yeah, to
Mhm.
choose roof, some corners. Okay, let's choose the corners here.
Mhm.
Okay, and he told us that here is surface in between nodes.
Mhm.
Those
Mhm.
43 to 46. Okay, that's area
Mhm.
here, which is degrees, raise,
Mhm.
all this. And when we go to parameters,
Mm-hmm.
he will ask he ask us which how
Mm-hmm.
which is the characteristic
Mm-hmm.
snow load.
Mm-hmm.
For example, there are few option for determining this. One options that we use our national annex for each country.
Mm-hmm.
For example, I can tell you that in Croatia for Zagreb, where load is in last time not
Mm-hmm.
so usual, but we have some higher level above sea, and
Mm-hmm.
there is big possibility of snow.
Mm-hmm.
We have, for example, characteristic snow load for 100-meter level above sea.
Mm-hmm. Mm-hmm.
Adriatic Sea is 1.25 kilonewton per square meter.
Mm-hmm.
So that's the characteristic value
Mm-hmm.
for Croatia, for Zagreb. For example, if we take in consideration some mountain area,
Mm-hmm.
for example, if we go in some in Austria in some
Mm-hmm.
mountain area,
Mm-hmm.
this value, the maximum I was working with
Mm-hmm.
on one of project is 12
Mm-hmm.
kilonewton per square meter.
Mm-hmm.
That's the pretty this is the biggest
Mm-hmm.
biggest snow load which
Mm-hmm.
I working with.
Mm-hmm.
So uh, after that we can choose load cases.
Mm-hmm.
I
It's
didn't
defined. Yeah.
define
Mm.
earlier
Mm.
snow case, but I can do it right now.
Mm. Nice.
From here
Mm-hmm.
I can choose, okay, generate new load case,
Mm-hmm.
and I can say here my load
Snow
case will name snow. uh, it will be in
in action. Yeah.
action snow
Which is.
I suppose,
Mm-hmm.
which is lower than 1,000 meter
Above
above
sea
sea.
level. Yeah.
Yeah,
Mm-hmm.
and if it's thousand, then using, you see
Mm.
here is defined in which category by Eurocode
Mm-hmm.
this category belong to.
Mm-hmm.
For C, then coefficients are
Mm-hmm.
a big difference. Okay, and if I say, okay, this is my new load, I get this
Mm-hmm.
parameter. Okay, and here is the shape coefficient,
Mm-hmm.
and when it's multiplied, this characteristic load, snow load 1.25
Mm-hmm.
is multiplied with this coefficient of shape,
Mm-hmm.
then I get my action,
Action.
uh,
Mm-hmm.
yeah, amount of snow load.
Mm-hmm.
When I click OK, I will get
Mm-hmm.
I
Mm-hmm.
will get my snow load
Mm-hmm.
here.
Which is
So that,
projection road.
yeah,
Yeah. Mm-hmm.
yeah, that's projection load.
Mm-hmm.
And for example, if I go to do same for dopage,
Mm-hmm.
I see here he asked me A B C D E F,
Mm-hmm. Mm-hmm.
and he show A B
Mm.
C D E F. So
Okay.
that means I have to make
One
uh,
auto. Uh-huh.
yeah. So I can go here, here, top,
Mm-hmm.
down, down,
Uh-huh.
top. Okay. Now I define my corner. I have parameter. I say the same value, 1.25.
Mm-hmm.
Okay. Load cases.
Mm-hmm.
I will define snow,
Mm-hmm.
snow, snow. Result, result. Okay. Okay. Sorry.
Mm-hmm.
Uh, one, sorry. Okay.
Mm-hmm.
And this is projection. Oh,
Mm-hmm. Mm-hmm. And what if it's not the gable roof, the cottage roof, like four sides or more than? Then you divide it. Uh-huh.
yeah, you should then divide it by triangles or like
Mm-hmm.
a rectangle.
Mm-hmm.
That's
Mm-hmm.
the
I see.
that's the that's the.
Mm-hmm.
But then you can separate them
Mm-hmm.
like one area,
Mm-hmm.
like this if there's possible.
Mm-hmm.
And then in this situation there are some it's not so precise to determine
Mm-hmm.
because you should take in consideration
Mm-hmm.
if there is possible that it's bigger amount of snow is keeping in this area,
Mm.
or there if there is overhanging, if
Mm.
this
Mm.
element is on the end, and is it possible for overhanging or keeping element at the end of this element. So
Mm.
there are a few more options which should be taken in consideration,
Mhm.
but for showing example
Mm.
how to deal with this,
Mm.
I think it's good representation.
I can imagine. I don't know in Grasshopper components if RFEM has this I'm sure they do. Maybe that will automate a lot to manually picking up these node numbers. Maybe the Grasshopper will automatically assign this load without picking up the node numbers.
Yes. Hmm.
Because you with the mouse click, you did it manually, but maybe with the
Yeah, yeah.
Grasshopper it will. Mm,
Mm, Probably
yeah,
we
we'll
should
see.
find.
Hmm.
Yeah, we will see. Uh, I just want to see one more option. There is um, there is one more option inside the RFM6,
Hmm.
and that's the automatically generating load from this
Geometry.
map
Hmm.
from map
Ah.
snow load.
Uh-huh.
Just a second. For example, just a second. See tools. Create auto checks.
Mm.
Option. Where it is now? Plain. No. Come. Snow. Is it possible to this now? Uh, okay, but this I can show you for a short.
Mhm.
Here is the on RFM site.
Mhm.
Here is possible to determine snow and wind load
Mm.
for each those country where,
Mm.
for example, if we go in Graz,
Mhm.
yeah, I can
Mhm.
I can go here,
Mhm.
and if I choose this, it will say this characteristic load
Oh.
will be 1.6 kilonewton.
Mm.
So I can go to Zagreb, which we are speaking about
Mhm.
now. You see,
It's low.
this
Mhm.
is value.
Mhm.
So that's the situation.
Oh,
So
nice.
you can see now by color,
Mhm.
those are categories, those are areas in Croatia which are for this area
Mhm.
is one amount.
Mhm.
For this area is a bit the mountain
Mhm.
area, and they are bigger. And then we going to sea level, and here is
Mm.
almost nothing, 0.4,
Mhm.
for example. And that this is very nice because then you can choose for each uh,
Mhm.
each
Yeah.
land.
Mhm.
You
And
can get
mhm.
precise amount of snow and wind loads.
Mhm. Mhm. That's nice. Mm.
Okay, and wind loads uh, almost the same.
Mhm.
What we can choose now here
Mhm.
is vertical
Mhm.
walls. Uh, if we are looking in flat roof,
Mhm.
or if we are looking for
Mhm.
dopage roof or flat roof, uh, dopage roof. So
Mhm.
we have now here four possibilities to choose on which surface we want to project our
Mhm.
wind load. For example, we can maybe define our
Mhm.
vertical walls for this small building. Just for example, base corner nodes. IJKL, it's down, That means please choose the base. Okay, I will choose this base.
Mm-hmm.
So I didn't. I
4.
forgot.
Mm-hmm.
Yeah, 4. I jumped over 1.
Mm-hmm.
Okay, 4, and then roof corner. A B C D.
Mm-hmm.
I'll try.
Mm-hmm.
Okay, and now I will. They are set wind perpendicular to.
Mm-hmm.
Uh, he took automatically height of this
Mm-hmm.
building, air density, and now I can choose wind velocity. So
Mm-hmm.
maybe if I just for sure get back here, we can maybe check if there's possibility to choose for Croatia, for Zagreb,
Mm-hmm.
wind load. Yeah, it's 20
Meter
20
per second.
meters per second.
Mm-hmm.
Yeah, okay. Then I can use 20 meters per second. That's okay.
Mm-hmm.
And what I should define now,
Load case.
yeah, that's the load cases.
Mm-hmm.
I don't have it. And what we speak about, I will create now
Wind.
wind
Mm-hmm.
uh, x direction, wind plus
Mm-hmm.
x direction. Okay. Uh, I will choose here. This is B A A B A B
Mm-hmm.
C D
Mm-hmm.
perpendicular to C D. That means in the x minus x.
Mm-hmm.
Okay.
Also, wind for the wind, you have to define each
Uh,
load case for the direction. Yeah.
yeah. And now he says CD.
Mm-hmm.
Sorry. I this is
BC.
the
That's
okay.
BC.
We'll choose. We'll choose
Mm-hmm.
another one. Okay. Okay. That's okay. Let's create this one. Plus.
Mm-hmm.
Okay. But I will choose this too. I will change this
Mm-hmm.
because this is minus
Mm-hmm.
x, and at the end here I need one more.
Mm-hmm.
Um,
That's why.
so
Mm-hmm. Mm-hmm.
now I have a manual for load cases, which are okay, split distance cannot convert into number. Split distance. Volume. What's going on with this turning factor? That's all okay. Let's try to do this. I know this should work very. Um, let's try just generating. Okay, it should be defined. Plus input minus eight. Well,
CNDs. Yeah.
minus yeah.
Mm-hmm. Cannot convert into a number.
Vertical walls with flat.
Mm-hmm.
Split. Yeah, sorry, my mistake.
Mm-hmm.
I think that this is probably because I choose it from bottom
Mm-hmm.
to the top, and I splitted my walls in two levels.
Ah, okay. So you have
So
choice.
I should choose base,
Mm-hmm.
my base here.
Mm-hmm.
Sorry, I completely
Mm-hmm.
forgot it.
So it's
I,
based on float floor.
Yeah, in this case, yeah, because I didn't, or did he recognize now my elements, corner nodes? Okay. Mm,
Cannot convert into a number. What does mean?
category 0, 3.0, okay. This is okay, that this is all okay. Load distribution, load cases, that's all okay. That's all calculated, and wall 1, 2, 3, raise wall area, that's all fine. AB in direction. What did we missed? Is there something which I entered with
Object load case, wind load number 1, input field split distance cannot convert into a number.
interesting? That's not okay. The surface loading.
Wall area, that is wall area 2, 6.
Surface loading. 2. Say like this. No, that one. Okay.
Then, no, this is x correct. But what did you define for x minus y and so on?
It's the same. I could define it like wind 0 degrees, 0, 90 degrees. It just define in which direction wind is blowing. So it means for this. And now he generated.
What did you do?
I did not.
What?
I just changed. Once to another one and back it to.
Okay.
I didn't do anything. Interesting.
So it should have been work like that way anyway. Yeah.
I don't know, but it should work normally, and then he split this load to the surface. That's the.
But the only 3 surface has the load cases, yeah, for the wind. What the other side of it world doesn't have.
There's
Okay.
yeah, now all those surface has, you know, it's wind x minus x plus epsilon minus epsilon. Okay, and this is just for just one example. Maybe we can just go to our load casing combination, and if we take a look, now he made many of these action combination, but still we have those 4 which are important for us for design. Maybe I can just try to put calculate all, and we will see if we put all good value. This part was interesting between I should check it why this happened.
But if you calculate big tower building, let's say,
yeah,
the calculation it will take quite a bit of time, yeah, in realistic project.
Yeah, depends. Usually, when it depends how you design make a calculation, because sometimes for such big buildings in some lands are necessary some senior structural engineer who will control this revisor for this project. I don't know, for in Germany I know that they are asking client can ask for some proofer or revision engineer, or there are pretty big uh, projects which are from uh, land interest, for some. Just then there is must have this revision, or for example, in Croatia, we should have the revisor for each project which is bigger from 800 square meters, or which has span more than 10 meters, or something, or some other cases. And in that case, you should define what is okay for this revisor, because some of them want that you split each level separately. So that means you design the slab, transfer load to slab under, and going from top down. For some smaller buildings, this and if it's regular building, of course, you can create complete 3D models. And in that case, probably the amount of reinforcement will be a bit smaller than this, let me say, traditional way, doing slab by slab or something like that. But that all depends about structural system of building. We should define clearly which system is there seismic activity. Is it possible to define to create a regularity in layout and in by height, and according that, then we can define and choose. Okay, maybe even if we have some underground stories, we can define, okay, top, this part above we will separate, calculate in separate model, and then after that we will transfer load to these underground buildings, and we will calculate these underground buildings. That's the structural logic in project start. So you should make a good strategy, and know good in which area you are working. Is it seismic activity or is not? Can you have a different statical system inside, or something? That's all thing which structural engineers struggling with during the design stage. Now we can go here. Yeah, and if we take a look our deformation, for example, if we choose just one slab, see this characteristic self weight it's here, live load is this one, and here characteristic is defined by this. So that's just one short example how we can choose, how we can check in for first statical for global deformation of our model. We can maybe say, okay, let's see x direction or y direction. There's no, because this is concrete structure, pretty strong, and pretty strong and stable. So I put 5 meter span, I think, in this direction, 6 in this. So this is pretty stable construction, and there's no bigger problem. But that's the point that we create stable. Yeah. Okay. But that's the short overview of some of those options, and I think that we already go to, we are almost middle time. I don't know how many, 50 minutes, I think. So maybe we can stop here, and then we can continue next time, maybe a little bit more explain this generation. Even we can maybe show short example of seismic seismic analyze. Even that's the specifics. In Croatia, you know that we had 2 earthquakes in past 2 years. Yeah, one in Zagreb and one 40 kilometers from Zagreb, and first was second was almost 6
6. Mm-hmm.
yeah by scale, and pretty big damage because Croatia is seismic pretty active
Mm-hmm.
area,
Mm-hmm.
and we can maybe just show a bit design, and maybe some picture
Mm-hmm.
also from
Mm-hmm.
that part. Maybe could be interesting
Yep.
in some structural engineer, because I know that this was the first time I actually live saw the damage which is caused by
Mm-hmm.
earthquake,
Mm-hmm.
and it's not good situation to have the earthquake in your near, but it was a pretty big experience for me, because I was almost 3-4 weeks on terrain with
Mm-hmm.
my colleagues. We are looking those damaged buildings
Mm-hmm.
and making first evaluation
Mm-hmm.
of security,
Mm-hmm.
and that's very nice. I think
That's very good.
there's big experience.
Yeah.
So
Great. Then next week, we looking at more seismic analysis and a little bit more detail about road, and then maybe you can move on to report part.
yeah,
Yeah.
yeah. We will make a short calculation,
Mm-hmm.
and after that skipped on the report,
Mm-hmm.
and then
And
going
then we
for
are
the
finished with the RFEM workshop for
yeah,
the basics.
yeah.
Great, Goran. Thank you very
Okay.
much today.
Thank you, mate. Thank
Thank
you.
you. It was really helpful. Then I'll stop recording. Then we see you next time, Goran.
Yeah.
Thank you very much.
See
So
you.
late.
Bye
Sorry.
bye.
Bye
Thank
bye.
you.